Pluto's story in modern astronomy is one of triumph, demotion, and redemption, challenging how we define worlds in our solar system. Discovered in 1930 by Clyde Tombaugh at the Lowell Observatory, Pluto was initially celebrated as the ninth planet, a distant sentinel guarding the outer reaches. For decades, it held this status, symbolizing the expansion of human knowledge into the frigid edges of space. However, by the early 2000s, advancements in telescope technology revealed the Kuiper Belt, a vast ring of icy bodies beyond Neptune, populated by objects similar in size and composition to Pluto. This discovery sparked a reevaluation. If Pluto shared its orbital neighborhood with thousands of comparable entities, could it truly be called a planet? The turning point came in 2006 at the International Astronomical Union General Assembly in Prague. Astronomers, facing the prospect of potentially dozens of new planets like Eris, initially thought larger than Pluto, crafted a new definition. A planet must 1. Orbit the Sun, 2. Be spherical due to its own gravity, hydrostatic equilibrium, and 3. Clear its orbital path of other debris. Pluto satisfied the first two criteria. It's round and orbits the Sun, but failed the third, as it resides amid the Kuiper Belt's clutter. Thus, it was reclassified as a dwarf planet, a category that also includes Ceres, Eris, Haumea, and Makemake. This decision was not unanimous. It passed by a narrow vote among a fraction of the IAU's members, leading to immediate backlash. Critics, including prominent figures like Alan Stern, principal investigator of NASA's New Horizons mission, argued that the definition was arbitrary and geophysically flawed. Stern contended that planetary status should focus on intrinsic properties, such as geology, atmosphere, and potential for life, rather than orbital dynamics, which could vary based on location. For instance, if Earth were placed in the Kuiper Belt, it too might not clear its path, yet no one would demote it. Public sentiment echoed this. Petitions circulated, and some U.S. states symbolically declared Pluto a planet. The controversy highlighted cultural attachments. Pluto was the only planet discovered by an American, and educational implications, as textbooks had to be rewritten, confusing generations of students. Pre-New Horizons, Pluto's mystique stemmed from its elusiveness. Ground-based telescopes, and even the Hubble Space Telescope, could only capture it as a blurry dot, smaller in angular size than many distant galaxies. This obscurity fueled speculation. Was it a captured comet? A rogue moon ejected from Neptune? Its eccentric orbit, tilted 17 degrees from the ecliptic and crossing Neptune's path, though never colliding due to resonance, added to the enigma. Spectroscopic data hinted at a surface of frozen methane, nitrogen, and carbon monoxide, but details were sparse. Pluto's size, estimated at about 1,473 miles in diameter, roughly 70% of the Moon's, and its thin atmosphere, detected via stellar occultations, suggested a cold, inactive world, perhaps a relic from the solar system's formation 4.6 billion years ago. Yet, Even in this era of limited data, Pluto challenged assumptions. Its largest moon, Charon, discovered in 1978, was so massive relative to Pluto that the pair orbited a common barycenter outside Pluto's surface, forming a binary system. This uniqueness foreshadowed Pluto's complexity. But without close-up views, debates remained theoretical. The demotion, while scientifically motivated to maintain order in classifications, felt like a dismissal of a world that had captured imaginations. It underscored a broader tension in astronomy, balancing rigorous definitions with the fluidity of discovery. As New Horizons launched in 2006, ironically the year of the demotion, it carried the hopes of resolving these debates, promising to reveal whether Pluto was truly a dwarf or a giant in disguise. This classification controversy extends beyond semantics. It reflects evolving paradigms in planetary science. Traditional views prioritize the 8 classical planets, but the Kuiper Belt's diversity suggests a continuum of worlds, from gas giants to icy dwarfs. Proponents of reinstating Pluto argue for a geophysical definition, emphasizing habitability potential over orbital clearance. Opponents warn this could inflate the planet count to over 100, complicating nomenclature. Meanwhile, cultural impacts persist. Pluto's story inspires books, documentaries, and even art, symbolizing resilience against arbitrary labels. In retrospect, the demotion may have been premature. As we'll explore in subsequent parts, New Horizons data painted Pluto as geologically active and atmospherically dynamic, traits shared with undisputed planets like Earth and Mars. This forces a reevaluation. Does size or location diminish significance? Pluto's case illustrates that scientific categories are tools, not absolutes, prone to revision as knowledge grows. Ultimately, the debate isn't about restoring Pluto's title, but acknowledging that our solar system defies neat boxes, with each world offering unique insights into cosmic evolution. The launch of NASA's New Horizons spacecraft in January 2006 marked a pivotal moment in planetary exploration, transforming Pluto from a pixelated enigma into a vividly detailed world. After a 9.5-year journey spanning over 3 billion miles, the probe's flyby on July 14, 2015, delivered a treasure trove of data that upended preconceptions. Far from the inert, crater-pocked ice ball imagined, Pluto revealed itself as a geologically vibrant dwarf planet with a surface sculpted by active processes, a surprisingly complex atmosphere, and tantalizing hints of a subsurface ocean. These findings not only ignited scientific excitement, but also reignited debates over Pluto's status, as they showcased features rivaling those on larger planets. At the heart of these revelations is Sputnik Planitia, the western lobe of Pluto's iconic heart feature, named Tombaugh Regio after its discoverer. This vast, heart-shaped plain, spanning about 620 miles across, is a smooth expanse of frozen nitrogen, methane, and carbon monoxide ices, remarkably devoid of impact craters. In planetary geology, crater density serves as a clock. Heavily cratered surfaces indicate ancient, unchanged terrain, while smooth areas suggest recent resurfacing. Sputnik Planetia's youth, estimated at less than 100 million years old, implies ongoing geological activity, possibly driven by convection currents in the nitrogen ice, akin to slow-boiling porridge. Polygonal cells on its surface, some up to 20 miles wide, support this, resembling Earth's mantle convection, but in a cryogenic form. This activity challenges models of small, distant bodies, which should have cooled long ago, losing internal heat from formation and radioactive decay. Bordering Sputnik Planitia are dramatic mountain ranges, such as the Hillary Montes and Tenzing Montes, soaring up to 11,000 feet high, composed primarily of water ice, which behaves like rock in Pluto's average surface temperature of minus 387 degrees Fahrenheit, minus 233 degrees Celsius. These peaks exhibit rugged, chaotic terrain, suggestive of tectonic forces or uplift from below. Cryovolcanoes, like Wright Mons and Picard Mons, add to the intrigue. Massive domes with central depressions that may have erupted slushy mixtures of water, ammonia, and methane. Unlike Earth's silicate lava volcanoes, these cryovolcanic structures represent a cold volcanism, unique to icy worlds. Evidence from New Horizons' Ralph instrument, which mapped compositions, shows ammonia-rich deposits around these features, bolstering the cryovolcanism hypothesis. However, controversy persists. Some scientists argue these could be erosional remnants rather than volcanic, as direct evidence of recent eruptions is absent, relying on indirect spectral data. Pluto's atmosphere, though tenuous, with a surface pressure about 100,000 times less than Earth's, proved equally astonishing. Primarily nitrogen with traces of methane and carbon monoxide, it extends up to 1,000 miles above the surface, forming multiple hazy layers visible in backlit images. These hazes, composed of tholins, complex organics formed by ultraviolet radiation breaking down methane, scatter sunlight, creating blue skies reminiscent of Earth's, but in an alien hue. The atmosphere undergoes dramatic seasonal changes tied to Pluto's 248-year elliptical orbit. As Pluto approaches perihelion, closest to the Sun, surface ices sublimate, thickening the atmosphere. At aphelion, it collapses, depositing frost. New Horizons captured this in action, observing haze production and possible clouds, hinting at weather patterns. Debates arise over the atmosphere's longevity. Models suggest it could freeze out entirely during parts of the orbit. Yet, observations indicate persistence, possibly sustained by geothermal heat or methane reservoirs. Beneath the surface, the most provocative mystery is the potential subsurface ocean. Gravitational data from the flyby showed Sputnik Planitia aligned antipodally to Charon, Pluto's largest moon, suggesting a mass concentration below, likely a denser liquid layer reorienting the crust. Thermal models incorporate radioactive decay in Pluto's rocky core, producing enough heat, about 5 to 10 gigawatts per estimates, to maintain liquid water mixed with ammonia as an antifreeze at depths of 60 to 120 miles. This ocean could be global or localized, insulated by the icy shell. Astrobiological implications are tantalizing. Tholins raining from the atmosphere might seep through cracks, providing organics, while hydrothermal vents could supply energy for prebiotic chemistry, mirroring Earth's deep-sea origins or Europa's speculated biosphere. Critics caution that without direct sampling, impossible with current tech, this remains speculative. Alternative explanations, like a slushy ice layer, fit the data too. The controversy echoes broader astrobiology debates. How minimal can conditions be for life? These surface, atmospheric, and subsurface discoveries collectively portray Pluto as a living world, defying its dwarf status. They compel revisions to planetary formation theories, suggesting that even small Kuiper Belt objects retain heat and activity longer than thought, perhaps due to efficient insulation or collisional histories. New Horizons data continues to yield papers, with over 100 published by 2023, analyzing everything from dune-like features in methane ice to dark equatorial regions like Cthulhu Macula, colored by tholins and pocked with ancient craters. Yet, gaps remain. The flyby provided only a snapshot, missing seasonal extremes or the far side. This fuels calls for future missions, like orbiters with ice-penetrating radar, to confirm the ocean and probe for biosignatures. In essence, New Horizons didn't just image Pluto. It exposed a paradigm-shifting complexity, blending geology, climatology, and potential habitability. These elements not only resolve some pre-flyby mysteries, but pose new ones, underscoring that exploration often reveals more questions than answers. A cosmic ballet where worlds whirl in eternal embrace, defying the loneliness of deep space. That's Pluto's moon system, a hidden gem unveiled by New Horizons that turns this distant dwarf into a captivating planetary powerhouse. Forget the solitary rock you might picture. Pluto commands an entourage of satellites that rival the drama of Jupiter's Galilean moons, packed with intrigue, violence, and whispers of ancient secrets. At the forefront dances Charon, a behemoth companion discovered in 1978. Sprawling 750 miles across, nearly half Pluto's girth. This isn't your average moon. It's so massive that the gravitational tug-of-war places their shared center of mass in the void between them, making Pluto-Charon the solar system's only binary dwarf planet duo. Locked in a hypnotic gaze, they face each other forever, spinning in perfect sync, like lovers frozen in time. But beneath Charon's icy facade lies a turbulent past. New Horizons captured jaw-dropping fractures, chasms plunging up to 6 miles deep and snaking hundreds of miles long. Scars from a subsurface ocean that may have boiled and burst before freezing solid, cracking the crust like an eggshell under pressure. Then there's the eerie red crown at Charon's North Pole, Mordor Macula, a dark stain not born from within, but painted by Pluto itself. Picture this: methane wisps escaping Pluto's gossamer atmosphere, drifting across the vacuum, and bombarding Charon, where radiation transforms them into tholins, those ruby-hued organic building blocks. It's interplanetary artistry, a subtle chemical kiss that blurs the boundaries between worlds, reminding us that even in isolation, celestial bodies converse in ways we barely comprehend. Venturing outward, the quartet of pine-sized moons, Nix, Hydra, Kerberos, and Styx, add a layer of wild unpredictability. These irregular shards, mere 20 to 30 miles wide, tumble chaotically through space, spinning without rhyme or reason, defying the orderly rotations of most satellites. Yet, against all odds, their orbits remain flawlessly circular and aligned in a single plane, stable for billions of years, amid the Kuiper Belt's cosmic debris field. How? Scientists speculate they rose from the rubble of a cataclysmic collision that birthed Charon, coalescing in a swirling disk, like phoenixes from ashes. This chaotic stability challenges our orbital mechanics textbooks, sparking heated debates. Are unseen forces at play? Or is this a snapshot of primordial chaos preserved in amber? Pluto's lunar family doesn't just orbit. It elevates the entire system to planetary royalty, forcing us to rethink what makes a world matter. If we judge by sheer dynamism, binary bonds, tectonic tantrums, potential ancient seas, Pluto outshines many so-called planets. This fuels the fiery classification controversy. Why cling to orbital clearance when geophysical fireworks scream for recognition? Broader still, Pluto's pristine state offers a time capsule to the solar system's dawn, contrasting with weathered giants like Earth. Its discoveries, echoed in the 2019 flyby of Arrokoth, a pristine snowman of merged lobes, illuminate gentle planet-building processes, rewriting origin stories from violent mergers to soft accretions. Looking ahead, the adventure isn't over. New horizons, fueled by its plutonium heart, until around 2030. Soldiers on as a deep space sentinel, aiming back terabytes of untapped data while charting the heliosphere's invisible shield against galactic rays. This intel refines models for interstellar travel, potentially safeguarding future astronauts. But dream bigger. Envision orbiters circling Pluto, deploying landers to drill through ice, radars piercing subsurface veils to hunt for liquid realms teeming with prebiotic soups. Tech hurdles loom. Vast distances demand ion drives or nuclear boosts, but synergies with missions like Europa Clipper could make it real. Pluto's tale is a thrill ride of redemption. Demoted yet defiant, it beckons us to the fringes where wonder reigns. Its moons and mysteries aren't just facts. They're invitations to ponder our place in the cosmos. As telescopes like James Webb peer deeper and data streams flow, one truth shines. In the universe's grand theater, the smallest stages often host the most spellbinding shows.